There are places on Earth where maps are considered only a minor detail. Places where the laws of evolution, the very thing that has governed life for hundreds of millions of years, suddenly break themselves. Imagine you are standing on a cliff, looking down at an island isolated for millions of years. Everything seems peaceful until a huge shadow glides through the bushes so lightly that its footsteps cannot be heard. A branch snaps, but breaks in a way that isn't caused by the wind. Here, creatures that should be small swell into dominant rulers, and large creatures turn into bizarre versions of themselves. Welcome to a world where nature asks itself, if I were to start everything over, what would happen? When we think of remote islands, the first thing that usually comes to mind is harshness. Small land area, scarce food sources, few shelters, and obviously fewer survival opportunities compared to the mainland. With such an environment, anyone would predict that island animals must evolve towards becoming smaller to conserve energy. But nature bends that thinking. In many cases, species that are inherently small on the mainland when living on islands develop into unusually large versions. Conversely, large species shrink into miniature versions. This entire phenomenon is collectively called the island rule, and it explains how geographical isolation can cause evolution to take two opposing directions. Gigantism. Small species become giant. Dwarfism. Large species become extremely small. These two trends seem contradictory, but are actually driven by a set of very specific conditions found only on islands. The first and most important factor is the absence of predators. On the mainland, small species often have to maintain their small size to hide easily, consume less energy, and be more agile when fleeing. But upon setting foot on an island where there are no cats, foxes, large snakes, or other professional predators, the pressure to stay small almost disappears. Without lurking dangers, growing larger becomes a safe option and sometimes a survival advantage. The second factor is vacant ecological niches. Many islands completely lack large herbivores, top predators, or even key groups of mammals. When these roles are left open, some species will fill the void, even if it's a bird, a lizard, or even a tiny insect. And to perform these new roles, they often have to be significantly larger than their ancestors. Finally, prolonged isolation results in island populations having small numbers and little gene exchange. This paves the way for genetic changes to occur faster and more powerfully, especially if the first group of organisms to set foot on the island, known as the founder group, happens to be larger than average. Under isolated conditions, that trait easily becomes a common characteristic of the entire population. When these three factors combine, the island becomes a strange evolutionary laboratory where species develop along paths that the mainland environment would never allow. And one of the groups of organisms that most clearly exhibits the island rule is giant birds. To see the strange power of this law, let's start with a world-famous name. The bird that transformed from a small, light pigeon into a symbol of extinction. The dodo. When it comes to island gigantism, no species illustrates it more clearly than flightless birds. This is the group of animals most susceptible to island rules, because they inherently had the advantage of long-distance travel, but upon arriving at an absolutely safe place, the wings that were once survival weapons became redundant. And gradually, subsequent generations became larger, heavier, slower. but also more adapted to the new island. One famous example, known by almost everyone, is the dodo bird. The popular image of the dodo is a strange, plump, waddling bird. But the interesting truth is, the dodo was originally a species of pigeon. Their ancestors were small, flying birds, capable of traveling long distances across oceans. And that's what helped them reach Mauritius millions of years ago. Here, they encountered a very different environment. No native predators, forests full of fallen fruit on the ground, and almost no competitors. And with no dangers left to be wary of, the dodo began to change. Over time, their bodies grew to nearly 17 to 18 kilograms, tens of times heavier than common pigeons. The wings, originally for flight, gradually atrophied into small stubs good only for decoration. Instead of expending energy to take flight, the dodo used that energy for muscle development, fat storage, and walking. Their beaks also became stronger, suited for a diverse diet of fruits, large seeds, and sometimes small animals. Some old records describe dodos having a very strong bite, showing they were not as useless as many earlier drawings depicted. This evolutionary path, large-bodied, slow, carefree, was effective for thousands of years. The dodo truly became the dominant creature in its own ecosystem. But that strategy was only effective until humans appeared. When Dutch sailors set foot on Mauritius in the late 16th century, dodos had no instinct to recognize danger. They didn't run, didn't fly, and even walked closer to observe. That made hunting them too easy. Less than a century later, in 1662, the dodo completely disappeared from Earth. The story of the dodo is often used to speak of human greed, but biologically, it is a prime example of the dark side of island gigantism. When evolution occurs in an overly safe environment, it creates a creature no longer able to cope with any external changes. And the dodo was not the only case. About 560 kilometers east of Mauritius is Rodriguez Island, where a bird species once existed, also descended from pigeons but evolved in a completely different direction, the Rodriguez solitaire. If the dodo was the easygoing uncle of the flightless bird world, then the solitaire was like an arena gladiator. The solitaire was even larger than the dodo. Males grew to nearly 90 centimeters tall and weighed about 28 kilograms. With a very large weight difference between males and females, a rare degree of sexual dimorphism in birds. The most distinctive feature, however, lay in its wings. Although not used for flight, the solitaire's wings have two unusual, hard, bony masses, the size of a bullet or a small ping-pong ball. These bony masses are used for attacking. Records from the 18th century state that solitaires fought by swinging their wings so forcefully that they created a sound like thunder. Later discovered bone samples also showed many healed fractures, clear evidence of frequent combat within the species. Why did the solitaire become so aggressive? While we cannot know with 100% certainty, most researchers believe that Rodriguez's environment was drier and more resource-scarce than Mauritius, forcing solitaires to compete fiercely for food and territory. While this is a conclusion based on modern ecological analysis, it remains purely scientific speculation, but it is logical speculation. Ultimately, like the dodo, the solitaire also did not survive after humans and invasive animals like cats and rats appeared on the island. They became extinct around the mid-18th century. The dodo and solitaire are just two initial examples, but they show one thing. Birds are the group that thrives most under island rules. But birds are not the only group that grows gigantic when living in isolated environments. Another group of animals also transformed in an unexpected way. Creatures that are familiar, small, and sometimes even scorned. Mice and other rodents. When thinking about giant animals, mice are probably the last group to come to your mind. But islands tell a different story. Just by being isolated from the mainland long enough, these tiny creatures can evolve in incredibly unexpected ways, becoming giant rats the size of a small dog. And the interesting thing is, this is not uncommon. On the island of Tenerife in the Canary Islands, there once existed a giant rat species named Canariomys bravoi. Compared to their closest mainland relatives, African grass rats, this species was more than 5 times larger, with a body size comparable to a Yorkshire Terrier dog. This is not a visual impression, but an actual size based on fossils. They were tens of centimeters long, had large skulls and powerful teeth, suitable for a diet including seeds, tubers, and possibly tough plant material that normal rats cannot handle. Why could a rat species grow so extensively? The answer lies in the island's ecological structure itself. No cats, no foxes, no large snakes, and no significant competitors. In that environment, becoming large was no longer a disadvantage. On the contrary, they had more energy to store, were less threatened, and could access a wider variety of foods that smaller rats could not handle. Isolation helped this process occur surprisingly quickly. In just a few 100,000 years, comparable to the evolutionary divergence between Neanderthals and modern humans. If the Tenerife rats grew large over a few 100,000 years, then their relatives on St. Kilda Island, Scotland, show that size exaggeration can happen very rapidly. The St. Kilda field mouse, Apodamus sylvaticus hirtensis, is believed to have appeared on the island thanks to ancient ships, possibly from the Viking Age, meaning only about 1,000 years ago. But in that short period, they had grown significantly larger compared to mainland European field mice. In St. Kilda, the cold, windy, and damp environment was not ideal for many other animals, but there were no cats or other predators threatening them. Conditions were almost perfect for the rapid exaggeration of mouse body size. This case shows an important thing. Island gigantism doesn't require millions of years. Sometimes it only takes a few dozen generations. In Indonesia, Flores Island is famous for 2 contrasting phenomena occurring simultaneously. The ancient human species, Homo floresiensis, was only about 1 meter tall, while the local rat species was the opposite, nearly 10 times larger than common rats, weighing up to 2.5 kilograms. This species has the scientific name Papagomys armandvillei, commonly known as the Flores giant rat. They are not monsters that attack people, but docile rodents living in the forest with a diverse diet ranging from fruits, young shoots, to small animals. It is noteworthy that Flores once had only one carnivorous animal, the Komodo dragon. But this species mainly eats carrion and large prey, so the Flores rat did not face significant predatory pressure. Combined with food available year-round, large size became an advantage, not a burden. These examples of giant rats clearly show one thing. When predators and competition are lacking, small creatures can evolve far beyond anything we imagine. And if there is any place that pushes this phenomenon to its most crazy extent, where evolution is almost completely unleashed, it is New Zealand, an island without any native carnivorous mammals. It is where the most bizarre giant creatures ever appeared. If there is any place on Earth that most clearly demonstrates the power of island rule, where evolution is unleashed and free to experiment with the strangest ideas, then that is New Zealand. The reason is very simple. Before humans arrived, New Zealand had absolutely no native carnivorous mammals. No cats, no foxes, no wolves, no bears, and even no large herbivores like deer or wild cattle. Except for a few bat species, the entire mammalian fauna was absent. In the absence of the animal groups that typically dominate terrestrial ecosystems, nature had to use available materials to fill those important roles. And in New Zealand, those materials were birds and insects. The result was a world almost unlike anywhere else. For many millions of years, the niche of large herbivores in New Zealand was occupied by a group of giant birds, collectively called moa. There were many species of moa, but the largest was the giant moa, standing up to about 3.6 meters tall and weighing over 270 kilograms, roughly equivalent to a small bison or a young giraffe. What's astonishing is that moa not only couldn't fly, they didn't even have wings. Not vestigial wings like an ostrich, but completely gone. In the moa's skeleton, the forelimb was reduced to a tiny finger-sized bone fragment, the only remaining vestige of its wings. No other bird species in the world forgot its wings so thoroughly. Why did moa become gigantic? Ecological evidence shows that the gigantism of moa was not accidental, but a result of the unique evolutionary circumstances in New Zealand. First, on this archipelago, there were no large herbivorous mammals at all, so moa took over their role in the ecosystem, becoming the primary animals responsible for grazing leaves, eating young shoots, and dispersing seeds. Additionally, New Zealand also lacked large predators, so developing gigantic size did not pose a disadvantage in terms of escape or survival ability. Finally, the abundant native vegetation with countless leaves, fruits, and young shoots provided a rich food source, allowing moa to develop large bodies without significant competitive pressure. Moa thus became the bird version of a giraffe, roaming ancient forests and dominating the land for millions of years. But even 3-meter-tall creatures were not at the top of the food chain. The apex position belonged to Haast's eagle, the largest eagle ever to exist, with females weighing up to 15 to 18 kilograms and a wingspan of about 3 meters. Although their wingspan was not as long as many modern sea eagles, their body frame was extremely muscular and powerful, almost like a winged lion. Haast's eagle's talons were comparable in size to a tiger's claws, powerful enough to pierce a moa's body with a single dive. Fossil analysis shows they were capable of direct attacks, grappling moa and killing prey many times their own weight. Some Maori legends describe a mythical bird, the puakai, believed to specialize in catching humans. The exact accuracy of this legend cannot be fully determined, but scientists agree that Haast's eagle possessed enough strength to pose a danger to humans, especially the first people who arrived in New Zealand about 700 years ago. However, when the Maori began hunting moa to depletion, Haast's eagle's primary food source disappeared, and this giant eagle also went extinct soon after. Although moa and Haast's eagle have vanished, New Zealand still harbors an island evolutionary legacy alive today: the kakapo, the world's heaviest parrot. The kakapo is a rare, flightless, nocturnal parrot with a distinctive scent combining honey and dampness, and it uses the lek breeding method. That is, Males gather and emit deep calls that resonate up to 5 kilometers to attract females. Weighing about 2 to 4 kilograms, the kakapo is a clear example of gigantism in small birds. Its ancestors may have been medium-sized flying parrots. Upon arriving in New Zealand, a place without dangerous predators, the kakapo evolved to gain weight, reduce flight muscles, and transition to a completely terrestrial lifestyle. However, when humans and introduced predators, cats, dogs, ferrets, arrived, kakapo had no defensive reflexes whatsoever. They stood still when facing danger, a reflex once useful against predators like eagles, but useless against cats and dogs. As a result, by the mid-1990s, only 51 kakapo individuals remained in the wild. Thanks to special conservation efforts, by 2024, the population has increased to about 244 individuals, but the species remains extremely vulnerable. New Zealand shows us the power of island gigantism at its extreme. Birds turned into herbivores, eagles turned into winged lions, and parrots transformed into the planet's oddest creatures. But it's not just giant birds and insects. Another group of creatures also grew unusually large, with appearances and behaviors no less crazy: reptiles and large insects in the Pacific. Birds were not the only group to bulk up when evolving on islands. In many parts of the Pacific, especially the areas around Australia, New Zealand, and nearby small islands, reptiles and insects also developed in very unusual ways. Some grew so large that they far surpassed their mainland relatives, creating creatures that were both strange and captivating, and sometimes a little frightening. The Komodo dragon is the largest living lizard, growing up to 3 meters long and weighing over 70 to 90 kilograms, with exceptionally large individuals reaching about 150 kilograms. They live on several Indonesian islands, including Komodo, Rinca, and Flores. For many years, it was believed that Komodo dragons were a product of island gigantism, that their ancestors were smaller and grew enormous due to less competitive environments. However, modern research shows the opposite. Their ancestors were already giant monitor lizards living in Australia hundreds of thousands to millions of years ago. It is possible that a population branch migrated to Indonesia, and the island environment helped them retain that giant size instead of shrinking like many other species. Although not a pure example of island gigantism, Komodo dragons are still proof that islands can be the last refuge for giant creatures, while their mainland relatives have gone extinct due to competition or climate change. Not far from Australia is the island of New Caledonia, home to the giant gecko species Rhacodactylus liakianus. With a length of up to 40 to 43 centimeters and weighing about half a kilogram, this is the largest living gecko species. That size is impressive enough, but their personality is what makes them special. This gecko species is described as easily irritable. They emit many different types of sounds: hisses, growls, and even whistling sounds similar to cave echoes. These sounds are not imaginary. Lychee gecko keepers worldwide confirm it. They are very territorial and can even attack their own kind, especially during breeding season. While this may sound fierce, it perfectly aligns with island rules. When there aren't many competing species, aggression sometimes helps them secure food sources and shelter in a limited environment. New Caledonia even once had an even larger gecko species, Hoplodactylus delcourti, or kawakawau, which is now extinct. If old records are accurate, This species could have been over 60 centimeters long, making it the largest gecko in history. Insects usually make us think of tiny sizes. But on Lord Howe Island, off the coast of Australia, there once existed an unbelievably large stick insect species, Dryococolus australis, also known by its evocative nickname, the tree lobster. This species is about 15 to 20 centimeters long, stout-bodied, and weighs nearly 25 grams, hundreds of times larger than many common stick insect species. When seen up close, they don't resemble sticks at all, but rather miniature crustaceans. What's remarkable is that this species was once thought to be extinct after rats were introduced to the island in 1918. But in 2001, scientists discovered a small surviving population on Ball's Pyramid, a sheer rock pillar in the middle of the ocean, with almost no land to cling to. No one thought any creature could survive there, yet they persisted for over 80 years. The survival of the tree lobster is an excellent example of how giant island animals can be extremely resilient, even when pushed to their limits. From Komodo dragons to irritable giant geckos, and then to stick insects surviving on a sea stack, reptiles and insects show that island gigantism doesn't just happen to birds or rodents, but almost any creature can amplify its size when conditions allow. However, there's still one more creature unmentioned, the absolute ruler of the terrestrial invertebrate world, famous for its ability to crack coconuts, steal pans, and sometimes drag away seabirds. That character is the coconut crab. In the world of terrestrial invertebrates, no species makes a stronger impression than the coconut crab, or Burgus lateral. This is currently the largest terrestrial crustacean, with a leg span that can reach over a meter and a weight exceeding 4 kilograms. Just seeing an adult coconut crab, you'll understand why many people encountering them for the first time often imagine they're seeing a creature straight out of a science fiction movie. What makes coconut crabs special isn't just their size. Although belonging to the hermit crab group, they have evolved in a completely different direction from their marine relatives. After gradually transitioning to a terrestrial environment, coconut crabs progressively lost the need to use snail shells for body protection, instead developing a natural hard shell. Their claws are among the strongest weapons ever recorded in invertebrates. Some studies measuring grip force show that each pinch of a coconut crab can reach over 3,000 newtons, equivalent to the bite force of a medium-sized lion. That very strength allows them to easily break open coconut shells, which many vertebrates also give up on. However, what's even more impressive is their ability to climb trees. Coconut crabs can climb up coconut trunks 10 to 12 meters high to find fallen fruits or forage for food. Despite their massive size, they still move at height in an astonishing way. And precisely because of their foraging habits, coconut crabs are famously known as island thieves. In many regions, locals and tourists frequently record scenes of them dragging away pots, pans, knives, or any item that smells of food. In some cases, they even attack and drag away adult seabirds, a behavior that has been directly documented and is no longer just hearsay. Coconut crabs are a perfect example of island gigantism. When living on islands with almost no large predators, their tiny ancestors could grow in size without much danger. Little competition, energy-rich food sources from fruits and animal carcasses, along with prolonged isolation over hundreds of thousands of years, created a creature far exceeding all common standards of the invertebrate world. These characteristics, from their large bodies, strong grip, curiosity, to their climbing ability, are all direct results of the adaptation process to the island environment. Today, though the presence of coconut crabs has been reduced by human impact, they are still considered the most iconic symbol of the island gigantism phenomenon. And when looking at them, we can clearly see how geographical isolation can drive evolution in directions that the mainland almost never allows. Looking back at the whole story, island gigantism is not a random phenomenon, but an understandable result of the environment. Lack of predators, lack of competition, and isolated populations. When one of these conditions is broken, the entire unique evolutionary system of the island also collapses. That is why many species only exist in records, while those that are still alive mostly only maintain populations of a few hundred individuals. Island gigantism is therefore not just an interesting topic, but also a clear indicator that evolution can take very different directions if input conditions change. And when island environments change, due to invasion, climate, or humans, these experimental populations are often the first groups to be affected.